Hello 108 students, Mr. McHugh here with you. Continuing our work on section 10.6. Got page 3 to take a look at here. Got a couple examples of solving for x when you've got the word log in your equations. Okay, so real quick, very important that you pay attention to both of these examples because you're going to see them in the homework, you're going to see them in the quiz, and you're going to see it on the test coming up. Good possibility you might even see them on the final. So let's see if we can handle these here to get you going here. Now, I like this first one because you look at this and you go, oh my word, what am I going? How am I possibly going to solve these? And then you're going to say, look and analyze what I'm trying to say. Recognize what you're dealing with. Again, I've said this 100 times. Kellen Moore. What is your read on this problem? You've got the word log on one side of the equation, do not have it on two, and I ask myself, why could I simply not convert it from log format into exponential format? So that's my recommendation. Now for me, we said this so many times you get tired of listening to me. Log of base 2 result is what? The quantity x plus 5 cubed equals the exponent of 4. For me, class, that is the key to doing these problems, is to know to say the words base, result, and exponent over and over again. So now you say, well, the result, I like to drop the result down. That's my way to do them. And stick to, and I say this in my class, stick to a continuous technique of how you translate these, or translate them. So I say the result equals the exponent raised to the the result equals the base raised to the exponent. Okay, this is a huge step right here, because once you've done that, number one, the word log is gone, and you're not going to take the log on both sides because that would not do you any good, and that would only compound the problem, would not make it easier. So now that I see this, we kind of reverting back to what did we do back in chapter 8 when we had parentheses, the variable was inside the parentheses and it was cubed. How do I get to that base here inside the parentheses? The answer is what? How do you undo cubing? You take the cube root on both sides. Okay, so you take the cube root on both sides, fine, and then of course you know that the base drops down, so you've got x plus 5 equals the cube root of 16 minus 5 on both sides, and now you're looking at x equals negative 5 plus the cube root of 16. But then you pause for a second and you go, oh, I don't know, can I pull out a perfect cube root? And then you remember what? The cube root of 16 could be broken down into 8 times 2. Cube root of 8 is 2. Okay, so you put a 2 in there and you're left with 2 times the cube root of 2. Okay, hopefully you followed all that logic right in there. A lot of little details in mathematics you got to keep track of. Okay, so now that we've done that, there's your answer. Okay, you're good to go. And now we're going to try example 4, looking at this one, and holy moly, you don't have log just one time. You've got, let's analyze the structure. You've got log base 2 on the left side of the equation. You've got it here, you've got it here. Here's your equal sign. Left side, right side, you've got log of 2. Okay, now your strategy for these is you got to go back and have a flashback to what happens if you've got subtraction. That's your key read here. You've got the same base and you got the results. You're doing the reverse quotient rule. Reverse quotient rule, meaning instead of taking something that's a log that's got in the result has got division, you've got subtraction, so you compress it into division. Okay, so now you can rewrite this expression that I've gotten up here can be rewritten as the log base 2 with the result of x plus 1 divided by x. Okay, and then you've got log 2 of 7, result 7. Okay, now the next key step is, here's what we've been working on, some of these rules, that Lawyer E's rules. When you have a log of the same base, what can I do to the results, class? Yes, set them equal to each other. So therefore you can also say that the logs negate each other, but you've got to have the same base on these problems. Okay, make sure you've got that. So now you take the result on the left side equals the result on the right side. Okay. Now we're getting easier and easier here. I see an x down in the denominator. How many times have we multiplied by the LCD of x on both sides? I multiplied there, maintain balance on the equation, and so I've got the x in the denominator, numerator cancel out. You're left with x plus 1 equals 7x. Oops, excuse me. Okay, so now you've got a what? Minus x on both sides, leaving you 1 equals 6x divided by 6, and you get x equals 1/6. That's a 6 there. Okay. Yeah, there's a fair amount of work in that problem. You've got to recognize a couple things. So take a moment to review that. I see subtraction, same base, so I subtract. I say compress. It's my word. Compress it into the result divided by the second result. Now that I realize I've got the same base on both sides, I can set the results of the left side equal to the right side. That's where you get x plus 1 divided by 7 equals 7. And then from here you've gone through lots of these, but go ahead and solve for x by multiplying by the LCD, clears it out, and then go through your regular algebra solving steps. Okay, Mr. McHugh here. We are going to say we're done on page 3, and I'm going to move on to page 4, and we got one more log equation to work with, and then we got some extra credit problems to look at for objective 3. So till then, take care, keep working hard, and I'll see you for page 4. Okay, bye.